All right, looks like Algebra 2, Lecture 5, 6, and 5, 7. OSA 2A21, the student will factor binomials and trinomials. We've done this in the past. Just want to do a little review of it for you. What we're going to do is take a look at some binomials and trinomials. We're going to look first to always factor out the greatest common factor, if possible, if there is one. Another way of thinking of that is I'm looking to find the biggest factor that both of these have, the thing that I could divide both of these by evenly, the biggest expression that I could divide both of those by evenly. So I look at this and I say, well, I want to factor out, they'll both divide by 6, and they both have an n. So I'm going to write that down. That's the greatest common factor. I'm going to open up a parenthesis, and then term by term, divide by this, Each one of these terms I'm going to divide by 6 and n. If I divide this by 6, it turns into a 1. If I divide that by n, it leaves the other n. So this just gives me n. Plus, if I divide this by 6, it gives me 8. And if I divide that by n, it gives me 1, and 8 times 1 is 8. So, and I'm finished. I factored out 6n because it was the greatest common factor that both of these have. I look at this and I see that won't factor any further. So I'm going to just do a quick check to make sure that I've copied it, factored it correctly by using the distributive property in my head. There's 6n times n is 6n squared. 6n times 8 is 48n. So I factored that binomial correctly. There we go. What I always want to do is check to see if I have a common factor. In this case, I had a 6n in both of those terms, so I factored it out, and then check to see if you can factor what's left. That's the name of the game today. So I look up here and I say, well, all of these will divide by 3, and they all have at least a b in them. That has a b, that has b times b, that has b times b times b. So the thing that they all have, all of them have at least b. So that's the greatest common factor. That's the biggest term that I could divide all 3 of these by evenly. So I write that down, and then I'm going to open up a set of parentheses, and term by term divide each one of these by 3b. If I divide this by 3 and b, I'm left with b squared. If I divide this by 3, that gives me 9. If I divide that by b, I'm left with the other b. If I divide this by 3, that leaves me with 14. And if I divide that by b, it leaves me with 1. And 14 times 1 is 14, so I won't bother showing it. Okay, so I've got the greatest common factor factored out. Now I want to check to see if this will factor. It's quadratic, so it might. It's a quadratic trinomial. So I'm going to try. It either will or it won't. And we'll find out real quick. If it won't factor any further, this is our factorization. If it will factor further, we're going to factor it. I'm going to take the square root of this one and put it here and here. I'm looking for factors of 14 that add or subtract to give me a 9. And I see that 7 and 2 will work. Doesn't matter where I put the 7 and where I put the 2. I can put the 2 here and the 7 here. What does matter is they have to add up to positive 9. The only way that can happen is if they're both positive. Then a quick check. Do they add together to give me this? Yes. Do they multiply together to give me this? Yes. If it meets both of those criteria, this quadratic trinomial has been factored correctly. So I factored this completely by factoring out the greatest common factor first. I saw that this left me with a trinomial that I tried to factor, and it factored also. So this is the complete factorization. Okay? Let's take a look at another one. We've got 2 more. I look at this one. I see that these will all divide by 4. So I'll write that down. And they don't all have an n in them. So the only common factor that they have is the 4. They don't all have n. So I'm going to write a 4, open up a parenthesis, and divide each term by 4 in my head. If I divide this by 4, I'm going to get n squared. Minus, if I divide that by 4, I'm going to get 6n. Plus, if I divide this by 4, I'm going to get 5. Alrighty, now I can always check to make sure I factored it correctly. I didn't do that on number 2, but it just so happens I did factor it correctly. I'm going to make sure that I did. There's 4 times n is 4n squared, 4 times negative 6n is negative 24n, 4 times 5 is 20, so I'm on a good start. Excuse me. I've gotten a good start here. Now I'm going to check to see if this will factor. I have a quadratic trinomial. I'm going to try to factor it. Take the square root of this one, put it here and here. I'm looking for factors of 5. Those are numbers that will multiply together to give me a 5, and the same numbers will either add or subtract to give me a 6. Well, those factors would be 5 and 1. 5 and 1 will add up to 6. It doesn't matter where I put them. I could put the 5 here and the 1 here. That doesn't matter at all. What does matter is that they have to add up to negative 6. And the only way that could possibly happen is if these are both negative. Then I do a quick check. If I multiply negative 5 times negative 1, do I get positive 5? Yes. If I add negative 5 plus negative 1, do I get negative 6? Yes. I've met both the criteria, so this is the correct factorization of that quadratic trinomial, and this 4 is a factor. And so we factored it completely. Alrighty, let's take a look at this one. 6, 24, 360, they'll all divide by 6, that's for sure. Put that over here. Do they all have an n? Yes, they do. In fact, all of them will divide evenly by n to the second power. That's n times n times n times n. That's n times n times n. That's n times n. So they'll all, I could cancel out n squared out of every single term. So I'm going to pull n squared out. That's the biggest factor that they all have in common. It's supposed to be a 2 right there. It looks just like a squiggle. That's better. And now I'm going to write what's left if I divide each one of these terms by 6n squared. If I divide this by 6n squared, I'm left with n squared. A quick check, 6n squared times n squared is 6n to the 4th. Plus, if I divide this by 6, I'm left with 4. If I divide this by n squared, I'm left with n. Think of it this way, if that doesn't make sense. N to the 3rd power divided by n squared, these will cancel, leaving me with n. Also, there's the properties of exponents. N to the 3rd divided by n to the 2nd is equal to, and we subtract our exponent, n to the 3 minus 1, which is, 3 minus 2. Which is n to the 1, which we generally just call n. N to the 1, we call n. It's an implied 1 there. So, when I looked at this and said I'm going to divide that by n squared, I got n. If I divide this by 6, what do I get? 60? Negative 60? Whoops, I grabbed the wrong marker. Negative 60? If I divide this by n squared, that's like dividing anything by itself, you get 1. Negative 60 times 1 is negative 60. So I factored out, hopefully successfully factored out, the greatest factor that each one of those terms has, the greatest monomial factor. And now I'm going to check to see that I've done it correctly by using my distributive property and seeing if I indeed get this trinomial. 6n squared times n squared is 6n to the 4th. N squared times n squared is n to the 4th. 6n squared times 4n is 24n to the 3rd power, or cubed, 24n cubed. And 6 times negative 60 is 360n squared. Multiplying this by negative 60 will yield negative 360n squared. Now I'm going to check to see if this will factor. It either will or it won't. If it doesn't, then this is our answer. If it does, then we'll go ahead and factor it. Write down my greatest common factor and try to factor this quadratic trinomial. Square root of this one, here and here. Factors of 60 that add up to 4, or subtract and give me 4. So let's see, 2 and 30 won't work. 3 and 20, no. 4 and 15, no. 5 and 12, no. 6 and 10, 6 and 10. 6 times 10 is 60, and 10 minus 6 is 4. I can subtract those and get a 4. So I'll go 10 times 6, and again, it doesn't matter where I put the 10 and the 6. I could put the 10 here and the 6 here. That doesn't matter at all. What matters is they have to add up to positive 4. And the only way that can happen is if the 10 is positive and the 6 is negative. They must add up to give me positive 4. Now my quick check is, do they multiply together to give me negative 60? Yes, they do. 10 times negative 6 is negative 60. Do they add together to give me positive 4? Yes, they do. So this is factored correctly. I factored out the greatest monomial factor first, and then I had a resultant quadratic trinomial, which I tried to factor, and it factored as well. Okay? And I want to stress, if you're taking a multiple choice and you've gotten this for your answer, and you don't see that, but you see this, this is correct also. The order of these factors doesn't matter. Because think of it this way, 3 times 2 times 4, it doesn't matter what order we multiply these in, we're going to get 24, no matter which order we multiply them in. So I can write these in any order. If you get this, and this is one of your choices, this is correct. Likewise, this could also be written like this. The same factors, just in a different order. That's fine. The order of the factors doesn't matter. This, you hardly ever see 6n on the right, but it could be. And this b plus 7 and b plus 2, we could switch places with those and it wouldn't matter. You could get this for an answer and you might see this among your multiple choice choices and it would be correct. Okay. So there we are. That's a little walk down memory lane. We're factoring binomials and trinomials by factoring out the greatest monomial factor first and then trying to factor what's left. In this case, this wouldn't factor. In the other 3 cases, they would. So there we go. You can do this, and this, if you practice this, it'll help you on the ACT because you always run into a couple of them.